So in this activity, we're going to review some things from lesson 4.2. We talked a little bit about this prior to break. If I had like 5 cubed and 5 cubed, I don't think I'd have much of a problem convincing all of you that the left and right side would be the same number. And they would both simplify to 125. Or if I had 8 cubed and 8 cubed, I don't think I'd have a hard time convincing you. And if I would do something like 12 to the fourth and 12 to the x, and I'm asking questions, so what does x have to equal to make sure the left side and the right side are equal to each other? Hopefully you understand that would be 4, because 12 to the fourth equals 12 to the fourth. So in this activity, what we're going to be doing is solving equations where we are rewriting each of the problems so they have the same bases. And if I have 12 to the fourth equals 12 to the x, or if I have 9 to the fourth equals 9 to the x, or I have a to the fourth equals a to the x. You know, in terms of these bases here, if the bases are the same, our focus really becomes the exponent. And so the exponent would be 4 to make both sides equal to each other. So I'm not going to go through all the problems on this handout, but I'm going to go through some of them because, again, just try to review from last semester. So on the 4.2, we're going to look at 1 through 6. We're going to look at a few of those, 3 of those, actually. We're going to look at 1, 2, and 3. On the second set, we've been working on that today, which is solving the equations. So I'm going to leave that for you to work on. And on the back side, there are 6 problems there as well. So again, those are the problems I'm going to leave for you to work on. So I'm hoping that most of this activity that you, or if you work with a partner, can complete. So my focus for this video is really the first section. So we're trying to get the bases to be the same. Because once the bases are the same, then what we're trying to do is make sure that the exponent on the left and the exponent on the right are the same numbers. So whatever this number is, it better equal 3, because I want 5 cubed to equal 5 cubed. So when x is 2, I'm going to have 5 to the third power equals 5 to the third power. So in problem 1, x is 2. In problem 2, again, this is where we don't have bases. So the question becomes, can I rewrite, do I need to rewrite both of the bases? Do I need to rewrite one of the bases? What is the smallest base that 3 and 27 share? So let's go think about that, and then see what you would do to rewrite the problem so they would have the same bases, similar to number 1. Turn your video back on when you're ready to continue. So hopefully you decided that the base that we're going to be choosing here is 3. So the left side, we're not going to change. We already have the base of 3. But the right side, we're going to rewrite the 27 as 3 cubed. I like to put the new base in parentheses when I rewrite it. That way I'm not going to lose sight of the multiplication step here that needs to take place. So it becomes 3 to the x minus 2 equals 3 to the 3 cubed to the third power. So the left side becomes 3 to the x minus 2. The right side becomes 3 to the 27. I'm sorry, 3 to the 9. Since 3 times 3 is 9. Since the base is the same, then our focus is how do I make the exponents the same number? So I'm going to take x minus 2 is equal to 9. So x is equal to 11. For the third problem, again, same thing. I want to rewrite the bases. Can I rewrite 125 to a 25 base? If the answer is yes, then that's what we're going to do. If the answer is no, then we got to figure out a way of rewriting both bases so they're the same number. And so, and again, I'm going to rewrite the base, for example, so that the base to that exponent, whatever that is in parentheses, and then the x plus 3 and the 2 are outside the parentheses, so we're not losing sight of the fact that we have to multiply. So, go ahead and see if you can figure out what the base we need to be written to, make them both the same bases. And then from there, so you can figure out the value of x. So hopefully you decided that 5 is the base. So 5 squared is 25, and 5 cubed is 125. So if I was to get rid of the parenthesis here by multiplying through by the 2 times the 2x plus 3, I'm going to get 2x plus 6, and 5 to the 6th, because 3 times 2 is 6. Since the bases are the same, our focus becomes the exponents. So what value for x will make both exponents equal to 6. Subtract 6 from both sides, so 2x equals 0. So divide by 2, and x is equal to 0. So I'd like you to work through the rest of the worksheet. The goal here again is try to complete all the problems, think about the first 3 problems and how that may help you with problems 4, 5, and 6. And we'll continue our discussion of 4-2 on Thursday if you can't figure something out. And hopefully you and your partner can work together as well.